7.2 Properties of Graphs of Quadratic Functions. So we found in 7.1 what A, B, and C have as effects on the graph. If the parabola opens down, we know that A is less than 0. The vertex of the parabola is the point with the greatest y-coordinate. Here I have a parabola that's opening down, so A is less than 0. The vertex, then, is called a maximum because it has the greatest y value. If the parabola opens up, I have a minimum value for my vertex. The y-coordinate of the vertex is the minimum value of the function. Here the y-coordinate for the vertex is the maximum value of the function. The parabola is symmetrical about a vertical line, this line. This line is called the axis of symmetry, and it passes through the vertex of a parabola. For all quadratic functions, the domain is the set of real numbers and the range is a subset of real numbers. So the domain is the values of x for which the parabola is defined. The values of x, if we look, the parabola is going to extend infinitely to the negative and infinitely to the positive. So I know that it's going to be the set of real numbers. The range, however, is the values of y for which the parabola is defined. If you look here, there is no y value that is less than 2. So therefore, our domain would be 2 and up. Sorry, our range would be 2 and up. It's a subset of real numbers. When a problem can be modeled by a quadratic function, the domain and range of the function may need to be restricted to values that have meaning in the context of the problem. So if we're shooting a basketball, we're shooting it from this point, trying to get it through a hoop that's about here. If we're shooting a basketball, the basketball isn't going to go below the ground, so therefore it has to be restricted to the first quadrant. Let's look at an example involving vertex and axis of symmetry. Sketch the graph of the following function. Determine the y-intercept, any x-intercepts, the equation of the axis of symmetry, the coordinates of the vertex, and the domain and range of the function. Here is my function, y equals x squared plus x minus 2. The y-intercept is where x is equal to 0. It's very easy to find because I know that my x value is going to be 0, so I can plug that into the x values in my equation to get 0 squared plus 0 minus 2. So y is then equal to negative 2. So my y-intercept is at point 0, negative 2. X-intercepts. I can find the x-intercepts using a table of values. I have my x and my y. Where my x is negative 3, I need to figure out what my y is going to be. I can do this by plugging negative 3 into my equation. So I have y is equal to negative 3 squared, that's 9, minus 3, that gives me 6, minus 2, gives me 4. If I want to find the y value for negative 2, negative 2 squared is 4, minus 2 is 2, minus 2 is 0, so negative 2, 0. I can continue doing this to fill out my table of values. So my x-intercepts are where y is equal to 0. If we look here, y is equal to 0 when x is negative 2, and y is also equal to 0 when x is 1. So my x-intercepts are negative 2, 0, and 1, 0. The axis of symmetry. We can use the x-intercepts to determine the axis of symmetry. Remember, it's located halfway between any two points that are equal distance from the vertex. If we look back here, I have these points. The axis of symmetry is exactly halfway in the middle of them. I also have these points. These are my x-intercepts. If I look here, my axis of symmetry is going to be exactly in the middle of them. That makes it pretty easy to find. So, because of this, I can find it by averaging the x-intercepts. So x is equal to negative 2, right, plus 1, divided by 2, so my x is going to be negative 0.5. That is the equation for my axis of symmetry. This is also the x-coordinate of the vertex. because if you remember, the axis of symmetry passes through the vertex. To find the y-coordinate, we can substitute x equals negative 0.5 back into the function. Y is equal to negative 0.5 squared minus 0.5 minus 2. Y is equal to negative 2.25. So the equation of the vertex is negative 0.5, negative 2.25. Since the parabola opens up, because my a is positive 1, I can now find the domain and range. So I have the set of points x comma y such that x is in the real numbers, y is greater than or equal to negative 2.25, y is in the real numbers. And my sketch of my parabola is going to look like this, now that I have my key points. Here are my x-intercepts, here's my vertex, here's my axis of symmetry, and I can sketch my parabola.